Okay, so let's go ahead and get started with 2-6. So this section is called the quadratic formula. Again, we already did kind of the couple worksheets of practice to get you ready for this, so hopefully it's going to go fairly smooth today. But these do obviously get a little more complicated. We've kind of looked at the most basic scenarios so far, and there are some tricky ones. So learning check, it's real simple. I can solve quadratic equations with the quadratic formula. All right, and quadratic formula again, it's on your formula sheet, it's on a bunch of stuff, but we'll go ahead and put it here again. This is one of these that you'll probably just have memorized. I know that sounds kind of weird because it's pretty crazy, but after you do a bunch of these, you just got it down. So same formula from the last couple days, the warm-up, whatever. I always call it opposite of b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to be using that for the next couple days for sure. The idea of this is it gives you the solutions. So we're pretty used to quadratics having two solutions. You know, when we factored them, they usually had two factors, and those two factors then resulted in giving us two answers, two solutions. We've seen when you graph these, you know, when you got like a graph and it crosses in two spots, it usually has two, those are the two solutions. This is just another way to find those. And you might ask yourself, like, why would I ever do this when I could just graph it or I could factor it or whatever? And the answer to that is you usually shouldn't prefer to do this. You should go about one of the other methods first. But there are places where you kind of have to use this. And we're going to talk about that today and then really more into the second part today. But the idea is this works 100% of the time. It works for imaginary answers. It works for irrational numbers like, you know, funky roots that don't simplify. It works 100% of the time, which is the nice part of it versus those other methods don't work in all cases. So we're just going to kind of practice it today. So here's the problem that we could probably solve with a couple methods. We could probably graph this and do some things. Maybe we'll talk about that too. But we're going to go right into the quadratic formula. So I've got my A, my B, and my C from the standard form. And I'm going to go ahead and just substituting these in. Now, when I do this, I don't write this x equals part every time because I just feel like you're writing a ton of stuff already. I pretty much just work at simplifying this. And I know that in the end, what I'm getting are my two solutions. So save yourself a little bit of writing and do that. So, okay, we start with the opposite of b. So it's the opposite of negative 4, which is positive 4, plus or minus b squared minus 4 times a times c all over 2a. Okay, and we get two simplifying. So 4 plus or minus. In our root, we're going to have 16. This is going to become a plus. Let's see, and then 12 times 9 is a 108. All over 6. Okay. Gonna go ahead and move up here. 4 plus or minus the root of, that's 124 over 6. And then 124, we're going to do a lot of this in the last couple of days. We need to break this root down. We need to simplify it. I do know 4 goes into this, and I think that's going to be our largest factor. Oh, oops. I'll get out of your calculator. All right, I know 4 goes into this, so I'm just going to start with that. So break that down to 4 and 31. Usually I do two separate roots, but same thing. So I know the square root of 4 is going to give me 2. And keep running out of space, so I'm going to keep doing this. So what do I get there? I get 2 root 31 over 6. And I know 31 doesn't go any further because 31 is a prime number. But I do know I can reduce this because every one of these numbers, these coefficients here, are all divisible by 2. So I can really break this down, dividing that by 2, this by 2, which is going to be a 1. So it's just root 31, and then a 3. So you can feel free to put a 1 here if you want to, but 1 times anything is just the thing. So at this point, this is as simplified as I can go. I know I can't break the root down any further. I already reduced the coefficients. So this really is my answer. And I usually leave it like this. You can write it as the plus and minuses like we talked about in the warm-up. But personally, this is easier to write. And even on the assignment today, it allows you to write most answers like this. Sometimes they'll say write it as a solution set. And if they say do that, like they'll put the little funky bracket up there. And they'll say like, okay, so you have 2 plus root 31 over 3. And you have 2 minus root 31 over 3. It's saying like these are my two solutions. But most of the time, you can actually write it like this. And I usually write it like this because it's just a shorter, simpler way to write it. Now, these are exact answers. This is kind of why this method is good and why it's considered to be needed sometimes. Sometimes you do need an exact answer. You can't afford to round this. And what I mean by that is, like, if I graph this, I can get rounded answers from a graph. And I'll show you just as like kind of a check here. And this is something that you can definitely do when you're checking answers and working things out. So if I graph this, you can do the same thing on decimals, even easier. We see it looks like this, and those are my two intersection points. Those are going to be at funky decimals for sure because I just got a funky decimal. So if I go to 0, let's say I want to get this first one here. So enter, enter, and enter. So it's negative 1.189, and a whole bunch of other change there. This is going to be equivalent to probably the subtraction one, the smaller one. So remember that number, negative 1.189. I bet if I type this in, it's the same thing. So 2 minus the square root of 31 and divide that by 3. Boom, there's my same exact number. So again, the plus to this is I have it as an exact root. The decimal is going to be a rounded answer. It's not going to be perfectly exact. So there's pros and cons to each way. So again, keep that in mind. You have something that can graph, whether it's the calculator or the decimal app, to check and to do things, and honestly, to be really valuable in these problems. Okay. All right, the one below it here. This is an example where, similar to the warm-up, we are going to get an imaginary value out of this. Now, you don't know that looking at it. I do because there's another little move we're going to learn later on. But for now, let's just go ahead and jump right into the problem. So we're going to go opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. All right, cool. Same thing. We get to simplifying. So we have 81 minus, and then 4 times 1 is 4, times 27 is 108, all over 2. Okay, let's go ahead and bring her up here. 9 plus or minus. 81 minus 108 is a negative 27. So that's the part I was talking about. This is how I know I have imaginary answers, because I'm rooting a negative value is going to give us imaginary values. But this does need to get broken down further. So let's go ahead and get into that process. So 9 is a perfect square that goes into this because I can call it 9 times 3. So I'm going to have 9. I'm going to pull the negative 1 out because that's going to give me the I. And then I'm going to pull the 3 out. This is always the hardest part for everybody that does this stuff. So they have a really hard time getting from here to here. So again, my thought process is I look at this and I say, what's a perfect square that can go into this? I come up with 9 because 9 is a perfect square. And 9 times 3 is 27. So that's where the 9 and the 3 came from. And then just because it was a negative value, I pull that negative 1 out separately because I know that's going to give me my I, or my imaginary value. All right, so now what am I working with? I have the 9 plus or minus. The square root of 9 is 3. The square root of negative 1 is I. And then root 3 is going to have to just stay as root 3. So at this point, I look at my coefficients. I have a 9, a 3, and a 2. There's nothing that goes into all of those besides 1. So that is my solution. Again, if you want to write it as a solution set, or you need to write it as a solution set, it'd be 9 plus 3i root 3 over 2, and 9 minus, 3i root 3 over 2. Again, I usually write it like this, but if it asks you to write it as both, a solution set or both values, it's like that. Okay, so there is a couple more on here. I figure you're really going to practice these. You're going to kind of get better at them. So what I would do is, I'm not going to do both these because they're actually really similar to each other. But right now, take a second and pause this and see if you solve this one out, see what you get. And then I'll do the same. Okay, so here's what we got. Everything substituted in. As you're working things out, you should get to this point where you have negative 6 plus or minus root 12 over 4. This tends to be where everybody goes and has trouble. So we need to break this 12 down. So think of a perfect square that goes into 12, like 4. So 4 times 3 were my factors I chose. I then square root the 4 to be a 2. Okay, our goal is to take whatever this is made up of and find something that's a perfect square so we can at least reduce part of it out of the root. At this point, you then look and say, okay, can I reduce these coefficients at all? Again, not the root. We don't care about the root. We're looking at the numbers here that are part of the fraction. Can I reduce those? Yes, these are all divisible by 2. And so, boom, that's how I got to here. This is a 1, but you don't have to write the 1. So, yeah, that's all you're going to see on the assignment today is practicing quadratic formula, but you're going to have a good amount of roots, some imaginary ones. And so it's kind of like all the harder versions of these problems. And these are really the ones that you're going to be doing quadratic formula with. The ones that are easier, like the ones that are on the worksheet that come out to easy numbers, that are whole numbers, you're going to do those by factoring or by graphing anyway. So these are really the ones that you need to be able to do. With the worksheet, we kind of just wanted to practice the simplifying part of this. So, all right, try out the OTI and see how you do.